Hello. Hopefully you can hear me. Just gonna make sure everyone can hear me first. Just let me know you can hear me in the chat, and then we'll make a start with today's lesson. Just waiting a couple of seconds to see if you can hear me. Wonderful, you can hear me. So we are looking today at the idea of algorithms. Now, this is not a practical lesson. This is a theory lesson, but we are still doing some of the ideas behind it. So there'll be a bit of code involved, but hopefully the ideas that we go through today will help you with your practical side of it if you struggle with that side of it anyway. So today, as I said, we're looking at algorithms. I have a question for you. What is a computer? Now, you may remember me asking you this question back in year 9, but if you answer in the chat, what do you think a computer is? And in the meantime, I'm just going to go through what we're going to go through today's lesson. So this might give you a bit of a clue if you can remember this. But in today's lesson, we're going to understand and explain the term algorithm. We're going to explain simple algorithms in terms of their inputs, processing, and outputs. And we're going to be able to understand pseudocode and flowcharts. So make sure you're answering that question about what is a computer in the chat. Obviously, if you're Googling it, that's not very helpful. Just use your brain. Think about what a computer actually is. So I'm going to go over the idea of an algorithm first before we go into the idea of a computer, okay? So an algorithm is a detailed, step-by-step set of instructions for solving a problem or completing a task. So I'll say that again. An algorithm is a detailed, step-by-step set of instructions for solving a problem or completing a task. Okay? Now, in computer science, programmers write algorithms that tell the computer how to perform a task. Now, an algorithm doesn't have to be a computer program, but all computer programs are a form of an algorithm. Does that make sense? So I'll say that again to make it really clear. All programs, all computer code is an algorithm. All code that is written are algorithms, but the set of instructions could be anything. So you could write a set of instructions for how to make a paper aeroplane, how to make a cup of tea, all of that kind of stuff. Those are all of the algorithm ideas. You don't need to write this down if you don't feel, it's kind of up to you. But this is, you can always go back through this later if you want, so you don't miss anything, to write any of this down if you want to. So, good. So, a machine that can be instructed to carry out instructions. Sure. So, coming back to this question that I've just seen Rayhan answer. So, what is a computer? Rayhan says it's a machine that can be instructed to carry out instructions or algorithms. Now, we did talk about this briefly in year 9, right? Can't remember whether it was right at the beginning or not, but hopefully some of this will ring a bell when it comes back on the screen. So a computer system is a mix of electronic hardware and software. It accepts data as input. It processes that data, and it provides us with an output, such as information or a physical action. But it can only follow the instructions we give it. So the answer for what is a computer is a machine, or, well, a system that takes an input, processes that information or that input, and gives some form of an output. So I think we talked about before the idea that our brains are actually a form of a computer, because our brains take data in. So we might see something in front of us that is an input into our brains. We process that information, and there's an output, such as a thought, or us being able to speak, or us being able to reach for something. Or say if the input was a hot stove, we touch a hot stove, the input would be feeling the heat, process that information, oh, that's hot, I shouldn't be touching it, and the output is that you jerk your hand back. That's the same idea. So as I've mentioned before, our brains work as computers as well. But computers, any computer, input, process, output. That's the important thing you need to remember. Okay. So I don't know if you remember this again. We've already done this task back in year 9, but what are the inputs, processes, and outputs for these devices? So you've got a smoke alarm, a microwave, and an iPad. So inputs, processes, and outputs for these devices. Oh, I've closed my little answers. So in the chat, please write about some of the inputs, processes, and outputs. See if you can remember them. Whoops. Okay, so let's do the smoke alarm first as an idea. Okay, so the input would be the smoke, or the button that you are pressing on the smoke alarm to test it. Yeah, so the smoke passes through the smoke alarm. Okay, and then the process is the detector that detects that particular detects the fact that there is no smoke there. There is smoke there even. So it detects the smoke. That's the process. And then the output. Yeah, what? Yes, Fraser, that's fine. Input is smoke. And the output is obviously the alarm itself, the noise, the beep, beep, beep noise that you get from a smoke alarm. Okay. With a microwave, you've got your buttons as your input. Some people might kind of go, oh, well, on a microwave, you put in the food, don't you? No, that's not an input or an output. That's just the thing that is being dealt with in the process of cooking your food. So the input is pressing the buttons. You might press 1, 0, 0, and then the process converts those numbers to a duration so that it can count, and also the intensity of how much microwave they will be submitting at the intensity of those microwaves. And obviously the output itself is the emission of those microwaves. It also has, most modern microwaves will have a little screen that show how long is left. So that's also an output, okay? And then the final one we can talk about is the idea of the output, the iPad. So let's see what Ray said about this. The iPad will send info for it to be processed, and the output will be when the iPad displays what has been processed. ooh, is it the iPad that sends the information? How do we get that information from the outside world? We tap on the screen, on the icons. That tap is processed by the iPad as, oh, they've tapped that there's a something on this area of the screen. That means that because this area of the screen has been tapped, that must mean that they want to open this app. Yeah. And that app will be opened. That will be the output. So it's the input is pressing on the iPad. The process is going, oh, where have they touched? What does that mean? That means they want to open this app as opposed to this app, for example. Yeah, exactly, haptic feedback. And then the output is opening that app or whatever it is that you wanted to have it displayed on the screen. Okay, so I hope that brings back a few memories of the inputs, processes, and outputs of these devices. So, write 2 steps their algorithms have order the need in. I'm sure you've been a bit confused by what I'm saying there. Let me say it one more time. Write 2 steps their algorithms have order the need in. Now, what do I mean by that? Right? I mean that actually algorithms need to have their steps in the right order. Like that sentence didn't make any sense when it wasn't in the right order, algorithms also need to have their steps in the right order. Okay. And a sequence, as I think we've discussed a few times before, is a series of steps in a logical order. So one thing after another, after another, after another. Okay. So some keywords for you to remember. An algorithm is a set of instructions, and a sequence is a series of steps in a logical order. Okay. Now, with regards to the idea of a sequence, if you were to follow instructions but in the wrong order, then things would start going wrong. Say if you were getting dressed in the morning and the instructions told you to put on your socks and then your shoes, then it would be telling, if you followed them in the wrong order, you'd get a wardrobe malfunction there, wouldn't you? So just the idea of sequence, making sure you follow your steps in a logical order. Okay, so let's move on. What different ways are there of representing algorithms? So there are a couple of different ways. We've obviously been able to see some of the ways that we've used in the past when we write our code in Python, but some of the other different ways are using a flowchart. Now, any of you who have watched The Big Bang Theory might recognize this flowchart. I would normally be showing you a video at this point, but unfortunately that would probably block my video, so I'm not going to do that. But the idea here is that he's got this algorithm which allows him to make friends, and he's drawn it up on his whiteboard, and he's decided that he's going to place a phone call. If they're home, he will ask them if they would like to share a meal, and then what is the response? If they say no, then he goes to this point. Would you enjoy a hot beverage? No. And then what is the response? If yes, then he goes down here. Otherwise, oh no, it's not, you don't want a hot beverage. So I'm going to go over here, and are we going to have a look at a recreational activity? What's one of your interests? And in the Big Bang Theory, he ends up getting himself into an infinite loop, which one of the other characters fixes by creating this counter which allows him to break out of that loop. And if the counter is over a certain amount, then it will say to choose the least objectionable interest, so the one that they are least likely to argue over, and then he will partake in that interest. Okay, and then begin the friendship. Now obviously this is a very silly algorithm, but you get the idea of what's happening here. There is a flowchart being used, so it goes from one point to the next. Now all of these symbols mean something different, and I'm going to go through what they all mean just now. Okay, so we've got a terminal. Okay, we've got an input or an output, process, decision, subroutine, and arrow. These arrows are really important. I'm just going to go through them in a minute. So a terminal will start or end a flowchart. You didn't see one in the previous option because he was using subroutines throughout his flowchart. Okay. So it usually has either the word start or the word end or finish in there to show that it's starting or ending that flowchart. Then we've got the input or output, which takes information in as an input. So it asks a question or that sort of thing, or it takes information out. So it gives information out as an output. So it in some way sends information out. So that might be like a print statement in Python. This box here is a process, which is always an instruction or a command. Okay, so it's basically do this. Okay, then this is a decision, which is the only shape which can have two arrows coming out of it. Every other shape can have more than one arrow going into it, but coming out of it can only have one arrow so that you know which direction you need to go. But a decision splits the flowchart into two options, yes or no. So it's like a Boolean decision going, is this the case, yes or no? You've got a Boolean answer there. Okay. Then a subroutine. We've talked a bit about subroutines as well. This completes a subtask before returning to the original flowchart. And again, I'll go into a bit more detail about those later. And then, of course, the arrow connects your different shapes together. Now, as I've just mentioned, only one arrow goes out of or into each shape, apart from decisions where there are two labeled arrows, yes and no. Okay, so decision will have a labeled arrow one way and a labeled arrow the other way. Okay, so I'm going to show you a couple of flowcharts, and I want you to work out where everyone will eat. Now, don't type this into the YouTube comments, because I'm going to give you a quiz to do to answer these different things, but hopefully you should be able to answer these quite quickly. So I'm going to give you a couple of minutes just to look at this one, and then I'm going to give you a couple of minutes to look at the one after it, and then I'm going to give you a couple of minutes just to complete the quiz. So I'm just going to open that up. So try and work that out. Where will everyone eat? If Brian has £6.50, Sarah has £2.80, and Hakim has £8.20, where are they going to eat? Try and maybe note it down on your phone or something if you can't write it down. In some way, note down what your answers are going to be, because the quiz that I'm going to send you is a quick fire quiz. So hopefully, if you've already got the answers, you can just answer really quickly. Okay. Right, I'm going to show you the other one as well. So hopefully you've worked that one out. And then, one of the things I want to talk about as well is the idea that we have this shape here to show our start and stop. We have this shape here to show our input. And in this case, it's an input, isn't it? Input or output. Okay. Here we have our condition or our decision, which is asking a question. Is cash less than 7? And then here we have our process, which is saying, do this, go to Greg's. Okay. So, gonna go on to this one here. Hopefully you managed to get an idea of what you wanted to do for the other one. But find the values of A for these inputs. So if the input was 5, what would the output be? If the input was 16, what would the output be? And if the input was 9, what would the output be? Okay. So I'm going to give you another couple of minutes just to try and work that out. And then actually I'm going to give you this straight away so that you can do that in your own time. In the chat, I have given you a challenge to complete on Kahoot, which you can do in your own time. You don't have to be here live even to complete that. So if you've seen that in the chat, you can complete that in your own time because of the way Kahoot have set up their new challenges, which is really useful. So once you've managed to figure out both of those, and then once you've completed your Kahoot, let me know, and then I will move on because I don't want to spend too long. Hi Fadja, if you only just can only just about see this one, then I can show you both, but I'd rather have the option of, the previous one is also there. They're both shown on the Kahoot, so it might take you a bit longer to work it out, but Rayhan, don't tell me. You've got to do it on the Kahoot. I'm gonna. Okay. Just a couple more minutes. can see that you're playing along there. So if you could, if you haven't already, make sure you have clicked on that Kahoot link that I've sent in the chat. And answer the questions that come up. Okay, I'll give you 1 more minute on that. And then we're going to move on. Okay, thank you, Rayhan. That's good. So it looks like most of you have finished, the ones that are playing live with me. A couple of you are still going, but I think, yeah, just a couple of you are still going. But I'm going to start to move on because we've still got more to get through. Okay, so hopefully you kind of get the idea of flowcharts and how they work, that you kind of go from one point to the next. And obviously we've got our start stop. As before, we've got this shape here denotes a start or a stop. We've got our inputs and outputs. It has a decision, it's got a question, is A equal to 16? Is A more than 5? Yeah. We've got our process, which is please do this. And then it will output, oops, let me go back. It's got your output, which is the same parallelogram shape as the input. And obviously you've got your stop at the bottom here. Okay, so moving on. If we think back to this kind of idea, this is an algorithm. Again, it's lots and lots of processes. So it just tells us to say, if you're happy and you know it, and then it says clap your hands. And then it says, if you're happy and you know it, then it says clap your hands. And it says, if you're happy and you know it, and you really want to show it, if you're happy and you know it, clap your hands. So obviously this is the song If You're Happy and You Know It, and I'm sure a lot of you are singing along at home now. How can we make this simpler? There's a lot of boxes here, and there's a lot of things that are just happening over and over again. So the way we can do this is we can obviously this isn't that complex an algorithm, but it's still an algorithm. Okay. It is important to break them down into smaller, simpler algorithms, and these smaller algorithms are called subroutines. And as I've said before, we've talked about the idea of subroutines. So here's a subroutine. Here's a subroutine over here called clap, which is, if you're happy and you know it, clap your hands. which that is your clap sub, right? And it's going to have clap times 2. That's a subroutine. And basically, anytime you see this kind of box, it goes, you need to go to the subroutine over here, which is called clap. And we're going to need to do that twice. Do you understand? Hopefully you do. So you go over here twice, and then you say if you're happy you know it and you really want to show it, and then you say if you're happy you know it, clap your hands. So you can see that the same thing is being used 3 separate times, but we only need 2 boxes here for them, rather than 3 and then, well, 6 boxes for all of those different parts. So that's the idea of a subroutine. It's that same thing I was talking to you about before, about picking up a spoon and putting it in the into the mix, and then mixing it, and then picking up your spoon and then tapping it on the edge of the bowl and then putting it back down again. We could just call that the subroutine called stir. We don't have to keep saying all of those instructions. We can just say stir. That encapsulates the idea of stirring, rather than us having to explain all of the different parts. Okay, so that's the idea of a subroutine. I wanted to go into the idea of pseudocode now, because we've talked a bit about flowcharts, but pseudocode is another thing that the exam board want you to know about. Okay, now a flowchart provides an overview of how to solve a problem, whereas pseudocode looks at your in-depth algorithms to solve your problems without having to worry about code syntax. Okay, it's almost computer code, but it's not quite. Okay, computer code will implement algorithms in a way that a computer can understand it. Now, in your exams, they will present you with code that is written in pseudocode. It won't be written in Python. It will be written in pseudocode. Now, pseudocode, as you'll see in a moment, looks very, very similar to Python or regular code. Okay, and it's the idea of pseudocode is that it is just got to be understandable and unambiguous. That means you aren't going to get it confused for some other thing. Okay, so what you need to think about with pseudocode is that it's somewhere between a flowchart overview, which is that sort of step-by-step idea that we just had a look at, and actual computer code. So flowcharts, you have to draw all your shapes out, whereas in pseudocode you don't really have to draw the shapes. And computer code, you have to make sure all of your syntax and all of the commas are in the right place and all of that kind of thing. Whereas pseudocode, you don't. Okay. In the exam, you don't have to write in a very specific form. The idea is that you have to make sure it is understandable and that it can't be confused for something else. Okay, so I'm going to give you some examples of some of the basic ideas that we have in Python and in pseudocode and in flowcharts, and just talk about the differences between them. Okay, so we've got variables, creating a variable. So we've got you're used to seeing this, where you've got x equals input, and that creates a variable and it prints out that variable. Yeah. In a flowchart, we'd say x becomes, with this arrow, user input. So that's kind of like what we're doing in pseudocode. You can see that we've got our input box here, which is our parallelogram in a flowchart, and an output box. So we've got 2 different ideas. We could even have written here user inputs x, or input x, or something like that, and then output x. Now pseudocode, AQA's version of pseudocode, is written in a very specific way. I'm just going to show you how that works, so that when you are reading pseudocode written by AQA, you don't get confused and go, what does that mean? So this arrow here is the same idea as a single equals in Python. So you remember how there's the difference between assignment and comparison. In Python, it uses the difference between a single equals and a double equals. In pseudocode, the difference is an arrow and just an equal sign. Now that might end up being confusing to you. In the exam, if you want to just write in Python code, that's absolutely fine, okay? As long as it makes sense, that's the main idea. So user input, this word here is this the way that AQA will write their examples of user input. So this is what the user input, the user will be inputting, a bit like we write over here, input, to put into that variable over there called x. And then obviously you're outputting x. Same idea, but instead of the word print, you're using the word output. And there's often a one-to-one relationship between pseudocode and actual code. So x is written the same idea twice. This equal sign is the same as this arrow. Make sure it's pointing towards the variable name, because otherwise it won't work. Okay, be a bit confusing. The equal sign is the same as the arrow, and this input open close brackets is the same as the words user input in pseudocode. Okay, output is the same as print, and in Python you need these brackets, but in pseudocode you don't. Okay, so the idea here is that this might look a bit more confusing, but I'm just trying to make sure you can understand how this works when it comes to the exam. Now in the exam, you can write in pseudocode, you can write in a flowchart, you can write in code if you want, as long as you are making sense. All right, moving on. So we've got our if-then statements. So here's an example of a flowchart version of your if statement. So you've got a question. Is x less than 3? That's a question. Yeah. If yes, it's going to output hi. Okay. And if no, it's going to continue. Okay. So same idea as normal if statement. If x is less than 3, then it will output hi. Else, nothing. Well, there's not even an else there. There's just a yes or a no. So when it goes to the yes, after it's outputted the hi, it will continue on with the rest of the program. So obviously down here, you'd have more of the program running. Okay. Then you've got pseudocode here. So if x is less than 3, then output hi. Now you'll notice here it's very similar to Python code here, but we've got the word then, and we've got this word end if, and you'll notice there's no indentations here. Those indentations need to be there in Python, but they don't need to be there in pseudocode. Sometimes when you're writing in pseudocode, you'll accidentally forget. If you're writing in an exam, for example, you might forget to see where you might miss out your indentations at the beginning of the line. So that's why we have the word then instead of a colon, and we have these words end if, because that shows us where this if statement is beginning and where it's ending. Okay, usually in Python we just have a gap here and we don't even have the words end if, and this is a colon instead. Yeah, obviously when you're writing in Python you want to type it a bit quicker, so you wouldn't want to type the word then. Typing a colon is much quicker than typing an entire word, isn't it? So that's why it looks a bit different than pseudocode. Pseudocode is just there to show us, make it really clear what's happening. The word then is shows us it's like English. And as well, we don't have our brackets for the output, and it's the word output instead of print. So comparisons, they have our yes or no answer. This here, if x is less than 3. This bit here is a comparison. Remember, if you've got a is equal to, then it will literally just have an equal sign rather than a double equals like it does in Python. Okay. Text has speech marks around it because, again, it will get confused with the idea of a variable that you might have created called hi if you don't have the speech marks around it. And your control statements in pseudocode need to have an end whatever, end if, end while, end for, whatever it is you're using. They need to have that end there to make it clear where you're going. All right. And obviously in Python, you've got if x is less than 3, colon, indentation, print, brackets, speech marks, hi, speech marks, close brackets. So that indentation there allows us to see where this bit of code continues. So if x is not less than 3, then it won't print out hi, and it will continue on with the rest of the program, wherever that is. And we know that from having worked on our code before. So just having a look at the difference between those two there, your differences are this colon here is the word then. There's no indentation in the pseudocode, and instead of the word print, we're using the word output. Don't need to use brackets in pseudocode, and we use our end if at the end, right? Okay, moving on to if then else. We've got our flowchart here. So is x less than 3? If it is, then it will output hi, and now we're adding an extra bit. Otherwise, it will output by. Strange little bit of code. Not sure why you'd say hi or by, but you get the idea. It's asking a question, giving an output depending on what the answer is. And you can see here that if x is less than 3, then it will output hi, and then it will go down to a different point in the code. It won't output by, because that's only going to happen if it isn't less than 3. Okay, so you won't do both of these things. Let's have a look at the pseudocode. So if x is less than 3, then output hi, like we did before. So we had that end if in there, but now we've got the word else, which we're very used to. All we're doing is adding the word else and then writing output by. Okay, and you can see that even though we don't have the indentations, you can see which bits go on where. Now, the indentations can be quite useful to us as programmers. So if in an exam, sometimes in the exam, they do put the indentations there just to help you out to kind of be able to see what's going on. But they should have these end if statements in there. If in the exam, you decide to use pseudocode written in a very similar way, or you aren't using, if you aren't using indentations correctly, then you need to make sure that you have this end if statement, because otherwise it won't be clear where you are starting, where you are finishing your if statements. Yeah, so control statements need to have your end whatever, end if, end for, to aid your understanding. And then obviously Python, if x is less than 3, colon, print, and you've got your indent here, print brackets, speech marks, hi, close speech marks, close brackets. And you've got your else with your colon. You will notice as well, it doesn't say else then, it just says else, okay? It says else, but it has a colon, right? And it doesn't need your end if or end whatever, okay? So moving on, while loops. asks a question. Is x less than 2? If yes, do whatever it is you want them to do. And then go back. Is x less than 2? If yes, do whatever it is you want them to do. That might include adding 1 to x, for example. Yeah, and it will keep doing that while x is less than 2. And if once x is less than 2, is not less than 2 anymore, it goes and continues on with the rest of the program. Okay, so if x is less than 2, then it will continue doing this over and over again. And if not, while it's not, it will continue on with the rest of the program. So, pseudocode. We've got our while x less than 2. Don't really need an end, then here, but we do need our end while. Same idea here, end while. Now, you can see here I've got my brackets, do procedure. That's an idea, kind of talking about having our, oh, what's the name for them? I've just completely blanked. Oop. The subroutines, that's the word. This is our subroutine called do procedure. We'll have the instructions for that somewhere else. And in AQA, they do tend to use these brackets at the end. Okay. Now, it also makes sure, I think a lot of AQA pseudocode uses underscores rather than camel case. So this is snake case, if you remember that conversation we had. Uses snake case rather than camel case for their variable names and their subroutine names, because it's a little bit clearer to be able to see it. It is, however, I find it just slower to type underscore than I do to type a capital letter, but that's just me. And in an exam, I think they just want to make it really clear what it is, rather than dot procedure instead of do procedure. Okay. Now, the criteria is the same for coding, flowcharts, and pseudocode. So your x is less than 2. They're all the same. The criteria is the same. Your control statements, again, need to have your end statement, end while, to make sure it's clear when this while loop actually finishes. Because you might have 15 lines of code in between this while, and then only 2 lines of code afterwards. But you might also have 2 lines of code in the while loop, and then 15 lines of code afterwards. It's not going to be clear unless you have that end while, or if you have an indent like we do in Python. So in Python, while x is less than 2, don't forget your colon, indent, do procedure, open close brackets. Now, you can write, this is basically a variable name really, isn't it, or a subroutine name, which is something you can create yourself. You don't have to put in the underscore. That's just to make sure that those 2 words become 1 word, because subroutines cannot be named as 2 words. It has to be 1 word, like the same idea with our variables. Okay. So now moving on to for loops, right? So for loops, count equals 1. Does count equal 5? If not, do the procedure and then add 1 to our count. This is very similar to our while loop. Okay? This is very similar to our while loop. But because the while loop is happening, we are, because this is a for loop, sorry, we are making sure we have that count in there. Now, in a flowchart, it's a lot harder to show a for loop properly, because you have to make sure you've got a decision block like this. Okay. Whereas in pseudocode, it's a lot easier, and it's a lot more similar to Python code. So it says for count becomes, this is your equals sign, 1, 2, 5. Okay, so for count equals 1 to 5 or arrow 1 to 5, do your procedure and don't forget your end for. So again, don't forget your end. Your for loops need your ranges. You don't have to put for count in range 1, comma 5 like you do in Python. You put in for count arrow 1, 2, 5. Okay. Now for count in range 1, comma 6. Now remember, in Python, it doesn't include that final value. So in pseudocode, we include the number 5 because it's a lot easier for us to remember that. But in Python, we need to remember that it doesn't include that final value in our range. Okay, and you've got your colon, for count in range 1, comma 6, colon, do your procedure. Okay, so hopefully that allowed you to have a good idea of what we were doing, the idea of pseudocode and flowcharts. Now, don't forget, you can always look back through any of these videos. I have put together a playlist of all of the videos that we have done so far, and I have put them onto I put the link to that on a document inside the tinyurl, so tinyurl.com/berrycs. Okay, so question in the chat. We voted for 2 1-hour lessons. I specifically asked everyone whether they wanted to do 2 lessons a week or 1 lesson a week, and so that's what the vote was for. And so if you didn't vote, that's where the issue was, one of the issues were. Okay, so I was quite happy to do 1 lesson a week if the majority wanted 1 lesson a week, but a lot of people did want 2 lessons a week. So that's why we are doing 2 lessons a week. I am not expecting you to do both lessons a week, but if you want to try and make sure you're staying ahead of the game, trying to make sure you're getting everything out of our lessons, then that is what that's for. Okay, I'm hoping that these lessons are helpful to you rather than frustrating, as some ideas might be a little more frustrating. Has anyone got any questions about today's lesson content, about any of these ideas? The term algorithm, explaining simple algorithms in terms of their inputs, processing and outputs, and being able to understand pseudocode and flowcharts. These are the things that we went over today. So hopefully you've been able to learn that and understand that in today's lesson. Ah, that's very nice of you to say. So yeah, hopefully this has been useful for you. Please send me a message if you have any questions about today's lesson or any other content that we've been through recently, or just if you want to kind of just ask anything in general. I hope you have a good have a good weekend, and that I will probably be seeing you next on Wednesday, same time. So the idea is I will be doing lessons on Wednesdays and Fridays at 12:40 every week until we're back in school. That's the idea. And obviously, if we're on holidays, then I won't be doing it those weeks. But generally, we should be doing live streams every Wednesday and Friday. So have a good weekend. I will see you on Wednesday.